So this video we're going to talk about the strengths of acids and bases. Well, one of the first things I'm going to expect to memorize are the 7 common strong acids. That means they dissociate 100% in water. There's no significant equilibrium to think of. You just get the proton coming off, and that's that. And so the list of the 7 common strong acids are HCl, HBr, HI. Conspicuously absent from this list is hydrofluoric acid, HF. These are the binary acids because they contain 2 elements. All right, now the oxo acids will be HNO3, nitric acid, H2SO4. This is the only one in the list that has 2 acidic protons. The first proton comes off 100%. The second one, not quite, but it comes off a significant amount. And then there is, let's see, H2SO, HNO3. Oh, there is just 2 more. HClO3, chloric acid, and then perchloric acid. All right, so this is the oxo acids, oxy acids. All right. So we're going to talk about what makes these strong in the first place. So let's look at the chemical structure of the oxy acids. Every one of them has the acidic proton as coming off of an oxygen atom. Clearly, you cannot have an acidic proton coming off an oxygen atom in these acids. There are no oxygens. All right? And the other part that is key to making it a strong acid is lots of electronegativity here. Okay? So the more electronegative groups you have here and the stronger electronegative groups you have here, then the stronger the acid is going to be. So let's just take a look at the first one, nitric acid, and see how this works. And that's going to be, all right, nitrogen, which is electronegative, and then attached to that nitrogen is another electronegative oxygen. So what happens is oxygen pulls electrons away from hydrogen, nitrogen pulls away, this oxygen pulls away, and this oxygen as well, and oops, sorry, no hydrogen here, sorry. There's only 1 hydrogen in nitric acid, not in sulfuric acid though. Okay, so when you look at the Lewis structure, of course we want to have an octet on the nitrogen, and so there's resonance forms where the double bond is here and the single bond is there. Okay, so all of these you can draw something similar, HClO4, ClO3, and so on. And if there's not enough oxygens pulling with the central atom, or if the central atom's not electronegative enough, then you won't have a strong acid. You'll have something that's a weak acid. Binary compounds, the strongest one of these 3 is actually HI, and that's because it has the weakest bond. As you go up, this bond is stronger, this bond's stronger, and when you get to HF, it turns out the bond is so strong it cannot break 100% of the time in water solution. Okay, so what about weak acids? What are they? All right, so weak acid, how can you know you have a weak acid? Well, first of all, it's not one of these. Second of all, if you see an organic acid, which has something like a COOH, which really, when you look at the Lewis structure, does not have an OO bond. Don't think it has an OO bond. Then the other clues you have a weak acid is that it does have a Ka listed, and the smaller the Ka, the weaker the acid. Okay, so these things will have Kas. They're just very large numbers, much greater than 1. And the other hint that you might have a weak acid is it's related to a weak base by conjugate relationship. And we'll see some examples of that in just a little bit. Okay, so that's it for the strengths of acids and bases and why they have the trends they do. Well, that's the acids. How about the bases? All right, the bases, strong base will be things like sodium hydroxide, etc., potassium hydroxide, lithium hydroxide. You might notice there's a pattern. First of all, there are a lot of hydroxides. They're group 1 hydroxides, which means they're very soluble. There is a limited solubility of some of the other hydroxides. So if you go back and look at your solubility rules, you'll find that most hydroxides are not soluble, and so they will not be strong bases because you just can't dissolve any. But some of the group 2s you can dissolve a modest amount, etc. All right, so as you go down column 1 in the periodic table, the hydroxides are strong. And then as you go down to column 2 in the periodic table, the hydroxides are strong. Sometimes the oxides of the elements will react with water to produce hydroxide as well. So let me give you an example of that. Caustic soda is sodium oxide. So that usually comes as a solid. We can add to water and we get 2 sodium hydroxides. So the oxides of some of the alkali metals are also strong bases because when you dissolve in water, they'll produce hydroxide. These already have the hydroxide. All the hydroxide is doing is coming out of the crystal lattice. Okay, what about weak bases? What are good examples of weak bases? Well, the weak bases, first of all, a big clue that you have a weak base is that it has a Kb. It has a molecular structure related to ammonia. So it'll have a nitrogen and a lone pair. So just like if you see carboxylic acid, you should think weak acid. If you see an amine, so another clue is there's the word amine in the name somehow. And then, of course, related to a weak acid. Okay, so one example, for example, is acetate, which is the conjugate base of acetic acid. Acetate is basic. It has a Kb, and the reason you know it's a weak base is because acetic acid is a weak acid. All right, so that's how you can tell trends in the strong and the weak bases, and some examples, particularly the organic types that you'll see, the amines and the carboxylic acids.